So this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 6, 7, 8, 9, 8, 7, 6. Well, this is like Perlin noise performance art. 9, 2, 7, 6, 1, 9, 4, 8, 9, 2, 1, 3. I pick 9 a lot. 2, 3, 4, 3, 4, 5, 6, 5, 4. Well, this is like Perlin noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise. This is Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise. Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise. This is Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise.
Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise. This is Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise that is. Perlin noise. This is Perlin noise that is. Perlin noise. This is Perlin noise that is. Perlin noise. So this is Perlin noise that is. Perlin noise.
Apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Well, this is like Perlin noise performance art.
Good morning, hello, and welcome to the Coding Train live on a Wednesday, where there's nothing else going on the internet today. Nothing. People aren't watching anything. They're here. Everyone's watching videos about simplex, Perlin, gradient, fractal, value, whirly, noise, right? Hello. My name is Dan Schiffman, and I, at the moment, am here every Wednesday at exactly this time. It is the morning for me here in New York City. You are here also, so thank you. Thank you for watching. I'm bursting at the seams to do today's topic, and I'm going to get to that in a second. It looks like people are saying hello in the chat. One thing you might have noticed, I instead of kind of waiting till I'm completely ready to flip the switch to start live streaming to YouTube, Utopia, YouTubitus, I instead start streaming with just the logo and playing some music while I'm getting ready. That way, at least something's up and running, people get the notification, takes some time for people to arrive. I do hope and plan to soon have that be something that's animated, maybe that says like starting in just a couple minutes, but you know, all in good time. I'm still a person who streams on the internet with a camera that shuts off every 30 minutes, so technical stuff is, it's happening, it's getting there. I'm starting to become a professional-ish person. One thing I just want to say that it's really an honor and a thrill and brings me a lot of joy and happiness is how many parts of the world people are from who are watching. I saw Ethiopia, Iran, Cambodia, Thailand, India, and those are just some of the countries that I saw people type in scrolling past in the chat. And I know that there's probably some US viewers there that is still, in terms of the viewership, when I look at the YouTube analytics, the highest number. But, and anything that I can do to make the content more accessible to international community and all sorts of different communities with access to technology and internet in different ways. I would love to hear from you. Maybe you're from somewhere in the world where you can't get this, but you want to. Maybe there's some kind of subtitles I could do, or bring on a guest, or help somebody else do videos in a different language. I don't know. This is a thing I would love to do. So it makes me happy. See France, Belgium, Poland, Belgium, Australia, Nepal, Portugal, Romania, France, Germany, Bulgaria. Amazing, amazing. Turkey, Russia, Pakistan, Belgium, Israel, Hungary, Egypt, Kerala, Netherlands, Poland, Bangladesh. Okay, I have to stop reading this. It's just it's too thrilling and wonderful. So let me make a few announcements first. I'm going to open up my browser. The spoiler alert, I'm going to talk about that. The Coding Train website. Let me yet again highlight the fact that there is this website. And one of the primary things about the Coding Train website, it is a place for you to share things that you have made based on videos that I put out, which the YouTube comment system isn't particularly great at. I mean, I'm trying to think of the good qualities about the YouTube commenting system. Oh, they have a little heart button. I get to press a heart button. I like that. I'm trying to think of other things. Anyway, so if I go here to, for example, my most recent Perlin, and when I say Perlin, for every single video I have ever made up until today, please just insert a footnote, a parentheses, a parenthetical, a subscript, a superscript. Please insert the year 1983. Oh, 1983. I was a young 10-year-old boy in Baltimore, Maryland, innocent of what would happen in the future to me, not realizing that I would spend my life blowing into a wood device that when air goes through it and then comes out makes a whistling tune. Anyway, this particular Perlin noise algorithm is an algorithm that dates back to 1983. And today we are entering the future. We are entering the 2000s, the 21st century. We're going to hit 2001 in this video, baby, and talk about Simplex Noise. Anyway, I was saying something. All right. The point of me showing you the website is this is a place for any challenge. And let's go to this one, Perlin Noise Loops, and go to the challenge. Here you can find the various links of things that I talk about in the video. You can find other related parts that are related to this challenge, other videos. But here's what I want to highlight, the community contributions. And currently the system for submitting your community contribution requires a pull request on GitHub. This might not be a thing you're familiar with or comfortable in how to do, but guess what? The Coding Train community is here to help you with that. Come on. Make your first pull request on GitHub. If you can't do anything wrong, you can't break anything, you can't do it the wrong way, we will help you. And so there's only one contribution right now from Carlos Ponce, source code here. Let's click on the project and take a look at it. Ooh, there's controls. There's a horn. Ooh, look at that. Oh, look at that. This is beautiful. X, Y, Z. Oh, I can put the axes there. I can make it not rotate. This is beautiful. And by the way, I did look at this before I started live streaming, and this is made with the P5JS WebGL renderer, which blows my mind. That's really awesome. Thank you for this submission. So I encourage you to submit your ideas to here. There was something, one thing I would love, just as a little note, a little tidbit. You will make me so happy if you do it this way. And maybe it should be more explicit in the guidelines. But if I go here into like the pull requests, oh look, there's another one right here, also by JC Ponce. If I click on it, and there's a comment here. What I would love, even though the URL to this particular project is in the actual files that were changed in the pull request, we can see it here. For me to look at it, I have to go in here and then do this and hit copy. It would be so nice if you could just put the URL to the project also in the comments you put here. So it's really easy to click on and see to make sure it isn't something that's not appropriate, or that there isn't a mistake, the URL's broken, that type of thing. Helps just check it. And I just love looking at them. So that would be wonderful. That would just bring me a little sparkle into my day to have that. Okay. What else did I want to talk about announcement-wise? Aha, yes! Google Summer of Code. So again, I'm not an official representative of Google Summer of Code. I don't work for Google. I'm not an organizer of Google Summer of Code, but I want to highlight this because I do participate in Google Summer of Code, and it is an excellent program for any of you watching who might be an excellent opportunity for any of you watching who are students who might like to get involved in open source and get paid to do so. So if you are, again, you should really double check the eligibility requirements from Google's official materials, but from my understanding, if you are a current university or graduate student, even if you are graduating this year, you are eligible to apply for Google Summer of Code. You can find all of the different mentoring organizations here. We can look through them. There's some that I'm a little bit familiar with. There's some that I'm quite intimately familiar with. And if I keep scrolling down, and eventually we get to the P's. There we go, the Processing Foundation. So the Processing Foundation is here. I'm gonna click on this. You can click to learn more. Anyway, maybe I'll come back to this another time. I don't think the deadline is for quite a while if people have questions. But I would encourage you to apply. Processing Foundation is the particular open source organization that I participate with for Google Summer of Code. I did notice, which was kind of exciting to me, that TensorFlow is on here. And I didn't check. I'm going to check as soon as I stop live streaming. I'm going to check this if the TensorFlow.js is part of what they're looking for contributions in for Google Summer of Code. But that's certainly a project that I have some passing familiarity with that I might encourage you to apply also. Oh, and Eclipse. Eclipse. I need like a love sound effect for when I have love for something. I used to spend a lot of time programming in Eclipse. I even saw Eclipse pass by on a YouTube video the other day that I was watching. I'll tell you more about that later. And I've been trying to find a time to do some stuff about Eclipse on this channel, The Coding Train. Oh, that would be nice. And I haven't thought of it. Found a reason to do so. And the thing that I've been wanting to do is actually show the steps to make a processing library, a processing Java library. And, this might have been more relevant, more timely if I had gotten around to it a year ago, 2 years ago, 5 years ago, 10 years ago. But I still think it has value today. And in particular, if you're learning about programming in Java, if you want to understand more about contributing to processing itself, it's good timing with Google Summer of Code coming up. So I think what I would like to do, and I don't think I'll get to this today, but I would like to turn the OpenSimplex Noise algorithm by Kurt Spencer that I'm going to look at into a processing library, and I could do that in a video. And then we could make a JavaScript library. I think there might already be a JavaScript implementation of Kurt Spencer's code. I'll have to look into that, but that's something that I am interested in. Wolfgang, oh, hey everybody. Wolfgang Amadeus Mozart is here. Oh, I thought I had some Mozart music. No, I have some Beethoven here. Anyway, Wolfgang Amadeus Mozart asks, do you prefer JavaScript or Java? I love them both equally. It's like asking me to pick between my children. Some days I like one more than the other. Some days one is complaining more, the other one's complaining more the next day. Some days one of them wants to give me a big hug, the other one doesn't, but then the next day the other one does and the other one doesn't. Not that they should be required to give me hugs, whatever. I don't know what I'm talking about anymore, but no, I will not tell you which one I prefer. I love them both. I love all programming languages. And they're all nice, and they all have their good points and their bad points. And some people like these and some people like these. To me, all the different paths for getting started and making stuff and expressing yourself and finding the joy in computing is a nice thing. All right. What is this? Ooh, Java, Linux Foundation. Processing Foundation. I need a thing for a thing. Someone give me some kind of, all right, so that is that. Let me close this out. Oh, now we're to the topic. So here's what's happening today. First of all, let me once again mention, I have a like whatever the equivalent of writer's block is for what it is that I do, I have that. Maybe you can help get me out of this YouTuber's block. Through a learning incentive grant from Google, from YouTube, I am working on creating a new playlist, which is entitled Working with Data and APIs in JavaScript. I've mentioned this before. I do have some videos that I have made previously on this topic, but they're mostly out of date and it could use a little refreshing. Plus, there's a lot of stuff I didn't get to. So I need to start doing this. I have to finish this playlist. My deadline is late April, early May. And so I want to get started on this. And so next Wednesday, come low or high water. I think I'm supposed to say hell, but I don't swear on my channel. I don't know if you've noticed that. I don't curse or cuss or whatever word you want to use. Because I'm secretly just like a little goody two-shoes. I had my wild period, my Rumspringa. But what is going on with me today? What did you put in here? Cafe chain that will remain nameless because you're not actually sponsoring me, but you could. I'm looking at you, frère à langer. Well, okay, anyway. I was saying something. I have to finish this. Oh, so come hell or high water. That's what I was trying to say, but I felt weird saying hell. It's not really a swear word, is it? I'm going to do this next week. So please help me out here. Give me your ideas, contribute to this. Hopefully there'll be I'm taking a train ride on Friday, and I'm hoping to work on this then. Is the audio gone? All right. Sounds really low right now. Okay, thank you for letting me know. There's mic issues. Let me see what could have caused that. Test. Oh, that's weird. Test. All right, I hear I've got it, everybody. Can't hear me anymore. All right. Oh, look at that. No. I'm aware of the sound problem. Does this work? I need a technical difficulty slide. Oh, people are saying it's okay now. On in the chat. We'll just let it fly, let it go, live on the edge, let your freak flag fly. No, don't nobody fly any freak flags in the chat. Keep everything on the level, please. All right, so that's that. So today, I have an obsession. My obsession is with noise algorithms. I have a new secondary obsession. That obsession is with looping noise algorithms. You have seen me spend all of my time on this for the last 2 weeks. There's got to be a stopping point at some point. Actually, there probably is no stopping point. Now the mic volume. Okay. Test. All right, let's restart the system. All right. Back. music playing, please let me know. I checked, I've checked a whole bunch of things, and everything is working as far as I can tell. So people are asking if the issue might have been, we hear you, okay, great. So the reason why I don't think the issue was the mic is because you couldn't hear the music either. And the music and the mic are completely separate audio inputs that are coming in different ways. So if they're both, if you're not hearing either of them, then it's got to be an issue on the, somewhere between the computer and YouTube, not between the audio devices and the computer. Okay. So I just have to mute something real quick. All right. Okay. Oh, I was doing so well. I had momentum. I had energy. I feel sleepy now. What time is it? Oh, good. As long as I get started coding by a half an hour in, that's a good thing. So, it's the mic. Wait, hold on. Audio gone, but music on. Oh, no, you could hear the music fine. Oh, okay. Okay, it is the mic. Let me, got it. Test. Test. I hear myself in the monitor. Oh boy. All right. The good news is I have another mic. Okay. Okay, let's check the cable here. I'm going to mute the mic because I don't want any like popping sounds to come up. I'm just going to play with the cables for a second. Okay. All right, let's see if the mic is back. The weird thing is, I don't see the level change in the monitor that shows me like this little green bouncing bar. All right, so right now you can hear me. I did switch out the batteries. I unplugged and plugged in the cables. Let's see if that fixes it. If not, the good news is I do have a second mic, but that'll take me a little bit of time to do that. So let me put this through my sweater and see if it works. Now, I hopefully the music doesn't like mess it up. So it is clipped to me now. And hopefully we're okay. Everybody seems to say it's good. All right. All right, so hopefully this is going to work. Let's play a little music to make sure that that's not causing a problem. I'm going to say once again, here we go. Sing it with me. It's the polar Cartesian coordinate song. It's the polar to Cartesian coordinate song. Okay. All right. Here we go. Now, let me go back to what I was saying before. I had all the different mic audio shenanigan problems. I have an obsession. Perlin noise. I have done a lot of videos about Perlin noise. I have done a lot of videos. You know what? Let me just get started with the actual coding challenge, because I'm going to explain everything that I'm going to do, and then I'm going to end up explaining it again. So I have this open, yes, and then, all right, that's good enough. Okay, all right, all right. Here we go. Simon, I see that you are asking me, did you see my long message? It's not possible for me to read long messages during the live stream, so I will check it out later. Thank you very much. Okay, here we go. This will be coding challenge 137, OpenSimplex Noise. Although I have to think about how to title this, because to be clear, what I'm going to do in this video is not implement OpenSimplex Noise. I'm going to use a particular implementation of OpenSimplex Noise in a processing sketch. So if it says coding challenge OpenSimplex Noise, somebody might think that means I'm implementing it, which I will not be doing. All right. I'm just checking the chat to make sure to make sure no one's saying there's an audio problem. And Paul says hello from Brooklyn. Hey, I live in Brooklyn. I'm not in Brooklyn right now, but that's where I live. Okay. Hello. Now, this video has been a long time coming, because let me tell you something. I've been living in the past. I've been living in 1983 my whole life. I mean, I didn't live in 1983 for 10 years of my life. Then I actually lived in 1983, and then the years went going. But since then, or at least for the recent times, those making these coding train videos about Perlin noise, I was living in 1983 all along. And I sort of knew that, but I never really bothered to look into it. I didn't want to know. I didn't want to know about what's happened since 1983. I am going to update my life right now, and your life too, to the year 2001, and actually more like the year 2014 and all the way to the present. Because today, I'm going to unpack what it means, to the best of my ability, what is the difference between the original Perlin noise implementation from 1983, something that came out in 2001, which is an updated version of Perlin noise called SimplexNoise by Ken Perlin himself, and some open source implementations that have been made more recently, notably by Kurt Spencer, called OpenSimplex Noise. So, a lot of stuff to cover here. This video will be approximately 71 hours and 32 minutes long. I hope you enjoy it. Now I will be prepared to begin speaking. Let's go travel back in time to 1983. Hey, what happened in 1983? No, I want to know the year 1983. Ooh. Let's travel back to the year 1983. Oh, it was a simpler time when Jim Henson's Fraggle Rock launched, and there's some bad stuff happened. Let's not look. I don't want to know what happened in 1983 anymore. Oh no, wait, what page am I on? All right, let me get to the point here. 1983, the original Perlin noise a type of what's known as gradient noise, was developed by Ken Perlin in 1983. Ken Perlin won an Academy Award for this work. It is the algorithm that Ken Perlin invented in 1983 forms the basis for the source code, the implementation that's in processing itself, in all these videos I've made about Perlin noise. The place where I learned to understand how Perlin noise works and how it's created was this webpage, which is no longer online, but I found it through Web Archive, Perlin Noise by Hugo Elias. And you might remember Hugo Elias from, the problem is when I look over here now to look at myself and what I'm pointing to, I see the chat. And then I see weird stuff happening in the chat. I have to distract myself. This page by Hugo Elias, this is where I learned and first understood how the Perlin noise algorithm works, why it's this kind of gradient noise, what this concept of octaves is, the idea of waves and amplitude and frequency. So I would encourage you to check out this article and look at it and think about and to. I'm just gonna can I start the whole thing over? No. I'll just start over from where I'm on the Hugo Elias page, because it's bad for me to stop because it's good for me to just keep going. Okay. Where I first learned about how the Perlin noise algorithm actually worked was from an article written by Hugo Elias. This page is no longer on the internet, but you can find it through web.archive.org. This is a wonderful introduction to noise functions, talks about random sampling, interpolation, amplitude and frequency, octaves, and looks at this kind of gradient smoothing process that happens to create Perlin noise and explains why you get these sort of patterns and how all this stuff works. There's actually even an implementation. But I'm not going to go through this today. I will point you to the idea of gradient noise. This is a key idea because the idea of Perlin noise is to smooth gradients in perhaps let's say we're considering a two-dimensional space, to smooth gradients within a two-dimensional space, squares on a grid. This is how we usually think of a 2D space. The reason why I'm highlighting this is because this idea of how this space is oriented, the geometry of this space, is the key distinction between classic, I would call classic Perlin noise, and simplex noise. All right, so we'll come back to that. Next stop on my Wikipedia tour is the page for simplex noise. So simplex noise is an algorithm for constructing n-dimensional noise. It's comparable to Perlin noise, created by Ken Perlin himself, but the key element here is fewer directional artifacts. So what do I mean by directional artifacts? Maybe you've noticed this in some of the videos that I've done before. Let me pull up this processing sketch. Look at this. Does it feel like it has this? This is I'm visualizing two-dimensional noise using a third dimension of noise as slices of animation. Do you feel this like kind of bouncing, like it's kind of like herky-jerky? Classic Perlin noise is kind of herky-jerky. It kind of gets to a point where it stops, it bounces. That's the sort of visual quality of a directional artifact. It doesn't feel smoothly continuous over long periods of time. And so this is really the innovation of simplex noise. Now the innovation has to do with symplectic geometry, which is really, and this is actually in an article that I'll refer to, but a simplex grid looks like this. So the core innovation is the idea that instead of smoothing the noise, calculating these gradients over a square grid, rectangular grid, a tiled system of equilateral triangles, and there's lots of variations of this, and this also generalizes to multiple dimensions, and symplectic, I can't say that word, but symplectic geometry, which maybe would be a topic for another day, to visualize some of this stuff in higher dimensions. But this is the core innovation. I couldn't possibly begin to say that I understand exactly how all of the pieces of the algorithm works and how this smooths out those directional artifacts. But I do want to highlight the work of, I lost the page here, but oh yeah, here, of Stefan Gustafsson. who is a computer graphics researcher, in particular the page of documents on Simplex Noise, and this PDF, which I'll scroll all the way back to the top, called Simplex Noise Demystified. So I read this on the subway home last night and on the subway to work this morning. And so I have some picture in my mind of how this works. I probably need to read it about 73 times more. But this will give you much more background into the difference between classic noise, which there's a nice, and you can see here this idea of these gradients, and simplex noise and how the tiling system works in multiple dimensions. So I encourage you to check that out. Now, one of the oddities about simplex noise is that there's a patent for it. This, if I'm correct, is the patent. Patent ES6 JavaScript. Inventor, Kenneth Perlin. You can download the PDF. This was filed in 2001 at the time of the invention of Simplex Noise. And there's lots of, this is an apparatus for generating an image. The apparatus includes a computer. The apparatus includes a display connected to the computer upon which images from the computer appear. I will stop now doing my dramatic reading of this patent. And so to me, I'm not a lawyer, I'm not an expert in this, but it's unclear to me what it would mean to use the sort of like literal version of the simplex noise algorithm, which is described in great detail here in the patent in, say, a processing library or processing sketch in an open source environment. So there is, fortunately, a post that was on Reddit that I found from 4 years ago from let me find the username, k.jpg, which is a post about this new version of what's called OpenSimplex Noise. So this algorithm is very similar. It's highly correlated and relates to the Ken Perlin Simplex Noise, but there are some key differences. And the code for this algorithm is published here on k.jpg's GitHub gist, OpenSimplexNoise.java. And which means I can use this in processing because it's Java. And if you scroll down, first you can look and be like, whoa, you gotta love anything that has a variable named squish constant 3D. Mwah! That is a beautiful variable name. But what I want to do is highlight down here. I looked. I gotta keep going. There's a lot of code. Whoa, there's a lot of code. Oh my God, scroll. Aha. Test, and then here. This is free, unencumbered software released into the public domain. So I believe this is something that I can use, and I'm going to use it in the context of this video. Boy, that was a lot of explanation. So what does this mean? So I want to do another video after this one, which is I just find every single piece of code I ever wrote using the processing Perlin noise function and do it again with OpenSimplex Noise. But I'm just going to do that just for one thing right now. One thing, and then I'm going to do a coding challenge with it. Maybe this isn't a coding, I don't know what. We'll see. This might get divided into 2 videos, I'm thinking now. All right, let me go here, raw. Let me do a nice big copy paste. I'm going to go to processing. Because processing, this is the sketch. I want to change this particular sketch from Perlin, classic Perlin 1983 noise, the noise function in the processing library, aka gradient noise. There is also something called value noise. There's all these fine distinctions between them. But anyway, it's easy to get confused. And somebody will write a nice succinct comment that I will pin to this page that has this all explained perfectly, I'm sure. I want to change this to use OpenSimplex Noise, and I want to examine and look at the difference in quality. And by the way, what does it mean? What do I mean when I say quality? So first of all, let's take a dive into this a little bit further. Let's go to processing.org/reference. Let's search on this page for noise. I'm going to click here, and I'm going to go down, and I'm not going to read you this whole description, but I'm going to go down here, and I'm going to read this part. There have been debates over the accuracy of the implementation of noise in processing. For clarification, it's an implementation of a classic Perlin noise from 1983 and not the newer Simplex Noise method from 2001. So why not? I mean, processing, by the way, was invented. It started by Casey Reese and Ben Fry as a project in 2001 at the same time. Why not update the version of Perlin noise that's in the library? So I think you could make a good case you could make an argument for both cases, but there is a different quality to the values. And there is now, historically, years and years of people making artworks, visual artworks and projects based on the quality of the Perlin noise, the noise function in processing. Just say noise. I'm just going to say noise from now on. And if it were to be updated, those projects would suddenly maybe not look the way they were intended, not look as beautiful, not look as compelling, not be as visually distinctive, because it's not that one is better than the other. I mean, there are reasons why you can say SimplexNoise is an improvement. Those artifacts and the smoothness and the computational complexity, those are things that had changed and are updated that are better according to a lot of different kinds of metrics. But it would make much more sense to have a separate library that you could use with processing to get OpenSimplex Noise. I mean, you could make the case, and there is a GitHub issue discussion about this, you could make the case that it might make sense to add to processing something called noise mode, in which case you could put in here, I don't know what the terminology would be. I would put in 1983. I'd put the year, no. But you could put in maybe gradient, Perlin, simplex, value. You could have whirly noise. In my research, look up something called whirly, W-O-R-L-E-Y. I want to really implement that noise. It looks really cool. So that could be something that you could do. I would say a good test case to see if this makes sense to add to the processing API would just be to make it as a library first, where you could pick your different noise mode. And then if everybody in the world is suddenly using it and it creates so much opportunity and possibilities, maybe then it would make sense to fold it to core. That would at least be my point of view. I'm not speaking as an official representative of processing. I'm just telling you my take on this. All right, now, so let's see the difference. Let's see the difference. This moment, living in the year 2001 in 2019 has really changed my life. People tell me in the comments to stop giggling. Oh well, I can't. New tab. So, wait, let me do save as. Let me save this on the desktop here. Save. Noise 3D. Okay, so one of the things, because processing is built on top of Java, I'm going to create a tab. I'm going to call it OpenSimplex Noise. I am going to paste in all that code. And this code, because it is written as a standalone Java class, will work just out of the box, right like this, with no changes in processing. It's really amazing. I could even, if I wanted to, have named the tab OpenSimplexNoise.java, and sometimes this is necessary if there's certain features of Java that the processing IDE won't understand, but in this case, it's not necessary. And I should say again, thank you to Etienne Jacob for showing me this and giving me lots of advice and help. I mentioned Etienne's work in several videos so far, but okay, so now we're going to change this over. The first thing that I'm going to do is I am going to create an object called OpenSimplex Noise. Just call it noise. I'm going to say noise equals a new OpenSimplex Noise object. And I'm just going to run this to make sure I'm not getting any errors. I am getting errors. Oh, weird. Amazingly, I did this yesterday. I swear I did this yesterday just to test, and I didn't have to make any changes. But this is one of those things. You can't have static functions in a class inside processing. It has to do with things being internal classes, yada, yada, yada. So what I'm going to do, let's try renaming this to OpenSimplexNoise.java. I think that will fix that issue. Great. So no errors, and maybe that's what I did before and I just didn't notice. It's running now. It's running the current noise algorithm, the noise function in processing. Now, we're getting close. What I'm going to do now is just change this, and I'm going to comment this out, and I'm going to say, actually, let me just do so. I'm going to show you something. It's kind of interesting. Let me comment this out. I'm going to put this in, and instead, what I'm going to do is I'm now going to say noise.eval. So that noise object has an eval function. The eval function takes one value. I don't know if it's supporting one-dimensional noise, but we can talk about how you can get that. You just fix the second dimension. But then I give it the arguments for 3D noise, x offset, y offset, and z offset. And I'm now using the library's noise function instead of the built-in noise function. Let's run this. I'm going to get errors. Cannot convert from a double to a float. So this is a bit of funny business that we're stuck with here. And this is what if turning it into a processing library, I would clean this up. Processing in its simplification of Java has basically ignored the existence of the data type double. Double is a floating point. It's not a floating point. It's a decimal number that has more memory, more accuracy, more digits than just floating point. And so here what I need to do is do something like, okay, well, I need to convert, which is called casting, what comes out of the eval function as a float. And then look at this. Now, interestingly, this looks so different. Now, there's a couple reasons why this looks different. One is, look at those. Look at those. I don't see a single directional artifact in there. Do you see any directional artifacts? There are no discernible directional. Look at this, just like flowing, smooth, noisy transition. Okay. Now, but it looks kind of weird. And one of the reasons that it looks weird is that the noise functions are generally designed to give you a number between -1 and 1, the mean being 0. Processing's implementation gives you a value between 0 and 1 as a sort of convenience. But so this multiplying by 255, this is why we see these vast areas of the color black, because any noise value that's less than 0 gets reduced to black, which is kind of interesting to note. Now, what I can do here, and I should really take out the third dimension to demonstrate this, but so if I change this to float n, and then I say float bright equals map n, which goes between -1, 1 to 0 and 255, now, whoa! That's not what I meant to happen, but that is cool. Whoa. What error did I make? Hold on. This is so weird. What am I doing that I did differently than yesterday? What numbers am I getting? Oh, whoops. I forgot. That was kind of cool, by the way, that this by accident, and I should not be having this print line thing here. Hold on. Okay, this is actually a really nice by accidental effect. I kind of love that I got this, but I forgot that I had previously multiplied it by 255 here, so that I need to take out. I'm sure the chat is yelling at me about that. There we go. This looks, whoops, this looks more like what we originally started with. It's a different noise algorithm. I'm visualizing it in a very literal fashion in a two-dimensional space, and there you go. Now, there's lots of ways we could alter the quality of what we're getting. I mean, one thing would be this increment value is really playing a big role in, and the z increment value is playing a big role in the quality of what we're seeing. Like, for example, let me make increment 0.1. Like, suddenly, look, that's what the noise looks like. Look at that. Ooh, this is really nice. Oh, I love this. And then, the z increment, if I made that really fast, then you're just seeing it sort of like changing really fast. And that now it has a lot more sort of chaotic randomness to it. But hopefully this is a nice addendum. Now, the quality of this has such a sort of like smooth and graceful visual quality, even that moving beyond just this very plain visual representation, there are enormous possibilities. And I would refer you to the work, let me just refer you to the work of Etienne Jacob, who makes all these amazing GIF loops using OpenSimplex Noise and a variety of techniques, all described in his blog post. So now, this ends this video, which I don't think was a coding challenge at all, just explaining a little bit about the background and difference between the different noise algorithms. And I will now do a video where I attempt to loop. I will do a coding challenge where I'm going to do two more things. I'm going to do one coding challenge where I attempt to do a two-dimensional noise loop using 4 dimensions. I'll explain what that means in a second. And then I think I also want to do, I'm going to do like a speed video where I just take every single thing I ever made with noise. I mean, it's not going to be everything, coding challenges wise, and like change it over to OpenSimplex Noise. All right? See you in those videos. Mwah. Simon is now giving me a message. In the coding challenge, you picked a random number between 1 and 1,000 or 1 in a million. To give you the maximum number in Java, you can use integer.maxValue and integer.minValue. Thank you. Okay. Okay. Whoa. Oh, this is what I want to do. Look at that. That is so cool. Whoa. Look at that. Oh my God. These are like ridiculously amazing. Jeez. I love these. Oh my God. Wow, look at that. Oh, that is wild. Oh, I want to make this. Okay. All right. So first of all, I'm just curious. Does anybody, that was my take on Perlin noise, simplex noise, a little bit about that history of those things. Does anyone have a, does anyone want to point out any significant corrections or things that you might know about? And now, I'm going to close all of this. And I'm trying to think. Yeah. Yes, instead of changing a spectral piano writes, this is a really good one. Instead of changing the place where you loop in the noise space, you can make a noise object with different seeds. Yes, that's what I was thinking of doing. Let's look at, does this take a seed? That's what I don't remember. So there is, oh yeah, it does, a seed. So I think this is what I'm going to do. Instead of doing different spaces, I'm going to take a seed. Do a coding challenge where you reproduce one of those animations. Flocking patterns by this kind of noise. Yeah, so this is what I'm going to do now. I just need to figure out what my demonstration is going to be. I mean, I think I'll do something simple. I mean, one thing I could do is just do a grid, like the flow field thing. So let me open up what I'm thinking of doing. So I have this example in Nature of Code book under agents, flow field 3D noise. Yeah. It's basically, let me take out the vehicles and show you what I mean. Oops. And I don't need this text. So this would be an easy thing for me to do. Easy. This would be a good starting point. Like I could make this loop. This is noise, OpenSimplex Noise in two-dimensional space, and I could use a four-dimensional space to loop the two-dimensional space. That sounds weird. I'm going to try to explain that. But I don't know. Is this visually interesting enough? Another thing I could do is I could just put a bunch of these in like random spots. I could go back and do the landscape. But I already have that terrain generator. Let's find that code. Let's find that code. Terrain generation shiftmen noise. So if I go to here, and then I do download code, let's download the processing version. And open this up. Like I have this, and so I would really like to add the simplex noise to this and see what happens. But this is a much more complex example. I feel like this is a second part. Let me do the first one. Let me do them both. I think I want to explain the stuff with a simpler case and then do terrain as a separate case. Because I already have built the terrain. and I can do the other one from scratch. Everyone's saying do this, this is better. I'm going to do this in 2D first to explain it. I will come back to this. Okay. Terrain on a sphere. Oh, that's a great idea. Not ready for that right now. Okay. Let me cycle the cameras. I really, really want to cover ES6 inheritance because it's a topic that I use in a lot of my programming classes here at NYU. And it's a topic I use in a lot of my programming classes here at NYU, and I would like to have some video tutorials to refer people to. Okay. All right. Oh, okay. All right. So let me put this away. All right. So let me just, what I'm going to do, close this. Ooh. Okay. I'm going to actually just start with this as the base code. All right. It's just, A. Baumstumpf writes, you have read up on Perlin simplex gradient noise and yet still call the processing noise function Perlin. It's a hard habit to break. I'm sorry. I know people get very bent out of shape about the particular distinctions between these noise functions, and I would like to be as accurate as possible, and I apologize for any inaccuracies and conflation that I have done in the past, and I'm sure will continue to do in the future. Hopefully I am providing a set of resources for people to be able to do a deep dive into this, to understand it further. Okay, so I guess if I'm being absolutely correct about this, let me see if I understand this correctly. The original Perlin noise, the original noise function from 1983 is no longer referred to as Perlin noise because Simplex Noise is Ken Perlin's updated version, so that's really at this point Perlin noise. That other noise, I would need some other name like gradient noise or 1983 noise because it's no longer truly Perlin anymore. But OpenSimplex Noise is based on Perlin noise, simplex noise, with this other slightly different algorithm. Maybe that's kind of right? I don't know. Terrain inside the sphere, please. Terrain on a hypercube. Okay. I'm really trying to get this right, everybody. I'm just doing my best here. Okay. Maybe I'll invite Ken Perlin over to come be the final word on this. He does work here at NYU, and I have I've been lucky enough to speak with him on a few different occasions and see him speak and be very inspired by his work. Okay. All right. Okay. I know what I'm doing now. Okay. Oleski asks, can you change noise method Perlin old O simplex by clicking on the canvas? Yes. But I'm not going to do that right now. That would be it would be great for someone to make, and actually in this paper, sorry, I know I said I was kind of done with the background stuff, but one of the things that I really like about Stefan Gustafsson's paper on Simplex Noise. Let me just find it again here. And by the way, there is also this implementation, which is Stefan Gustafsson's speed improved simplex noise algorithm for 2D, 3D, and 4D. I just wasn't clear what the license is about this. So that I wasn't sure about it does say the code was placed in the public domain. You may use it as you see fit, but attribution is appreciated. So I said, it's unclear to me what violates and doesn't violate the patent. And at least on the Reddit thread, there are some pretty good arguments for why OpenSimplex Noise doesn't violate the patent. But what I wanted to show you, which I think is really nice about this particular article, that I would recommend you check out, let me find this diagram, is there's a couple of visual demonstrations of all the different noise algorithms side by side. I think this is where I saw it, yeah. So classic Perlin noise. Maybe I'll say classic Perlin noise. How about that? Perlin noise classic. That's what I'm going to say. And simplex noise, you can see the sort of visual differences just here mapped onto a terrain. Fourier series drawing a Perlin noise terrain. I hope somebody does that. All right, coding challenge time. I mean, I could actually just loop this, which would be kind of interesting. But I don't know why. Yeah, actually, you know what would be kind of interesting would be to right? Like, because what I could do here is I could say, n is greater than 0. How do you do those ternary things? 0, something like this? Is that right? What's the chance I got that right? Oh, I did. Like, this would be kind of fun to loop. Like, and then if I change the incrementation value, no, but like this, let's do it this actually. Yeah, looping this would be kind of interesting. Because it would be surprising to see this loop, right? But I think I want to go with all right, let me, and then I need, sorry, the other thing I need is yeah, I have an idea for what I'm doing. I think I have an idea now. I'm never getting to that inheritance stuff, am I? I need just the GIF loop code. Download this. Or actually, it's just one. Yeah, I just need this. And put this on the desktop. And I can close that. I don't think I need this. Great. Oh. And this is doing this. Great. Okay. All right. All right, I am ready. Classic Perlin noise is a good way of calling it. Just there are so many people calling fractal noise Perlin that is often hard finding actual articles about either. That makes sense. That makes sense. That is a good bit of feedback. Okay. Fractal noise, yes. That's another term I should have used. Okay. Okay. So wait, I need this to go back to what it was. All right. Okay, I got it. I'm going to do two things in this video. All right. Three things, who knows? All right, I got to get started. Oops. Uh-oh. Come back, camera. There we go. 11:36. Okay. Hello. Welcome to an exciting moment for me. Let me do that again. So Pradesh in the chat says, am I the only one who is curious to see the 4-dimension animation? So to be clear, what I'm going to show you is still going to be visualized in 2 dimensions. I'm using the 3rd and the 4th dimension to create a closed loop of the values that are in 2 dimensions. That sounds like a really weird thing, and I will try to unpack that a little further. I do actually have a video about a hypercube, a 4-dimensional cube, a tesseract visualized in 3 dimensions. That you might want to refer to if that's what you're kind of looking for. But this is really, I'm using a higher dimensional space to pick values that are still being visualized ultimately in 2 dimensions. All right. Hello, welcome to a coding challenge entitled 4D OpenSimplex Noise Loop. That's got to be like a clickbait title if I ever heard one, right? Anyway, let me thank somebody. And Mathieu, I didn't have this prepared, so you'll have to like edit this. The artist Etienne Jacob, who I've referred to in like the last 307 coding challenge videos that I've made because I keep doing this topic over and over again, has been really an inspiration for these videos, makes these amazing noise loop GIFs, and I've talked a little bit about some techniques for doing that using classic Perlin noise, the noise function in processing, which you can also refer to as fractal noise. And I've recently, through feedback and research, been turned on to this idea of simplex noise and OpenSimplex Noise, and I made an entire video all about that and the differences and a little bit about the history there, so I'll refer you to that video if you want to find out more. In this particular video, all I'm going to do is I now have the processing 3D noise example, which you'll see nothing is 3-dimensional here. There's really a 2-dimensional space of noise, and the 3rd dimension is what's creating the animation. Frame, you can think of that 3rd dimension almost as time. I'm seeing frame by frame by frame. What I want to do with this is take this and make it loop. I want to have this noisy scene, and this is using OpenSimplex Noise, which has a different quality and character to it. It has less what are known as directional artifacts that I referred to in the previous video as like this herky-jerky feeling of what kind of the noise algorithm could sometimes do. It feels to like stop and turn around. And so the smoothness of this is quite pleasant and has a kind of visual quality that's, for a lot of scenarios, better. So there's more to say about that. You could go watch the other video. But what I want to do is make this run just over a few seconds and then render it as a GIF that loops seamlessly. And if I were to do that right now, if I were to just say, well, hold on, time out. Let me make an example of this really quickly. I mean, this won't, I don't think this needs to go in the video. But I think this would be a good demonstration of this. Oh, whoops, I want to do this. No. Oh, I didn't fix that yet. Where am I? Where am I? What's my sketch called? Noise 3D? Am I on the desktop? So confused. I am. Oh, it's this. FFmpeg dash, oh, shoot, what is it? I think it's dash I, image to, no, it's dash F. Dash F, image to dash frame rate, 30 dash I, output, no, I'm in the directory, what did I call it? A no loop dash percent 3d.png, no loop dot gif. Oh, wait, I really should stop it from rendering. So it's not like in the middle of doing both at the same time. Let's do that again. Yes. Does this make the case that I want to make? Effectively. Oh, Mac Preview won't show me a... Oh, what is wrong with computers these days? Does that look like it's looping? I don't see it. It actually kind of feels like it's looping. There's got to be an obvious, I'm going to look closer. Oh, there we go. It just took forever to get there. Did I just have like way too many images? Yeah, I think I just had way too many images. Let's, hold on. Let's render this again. Let me just do it in the outside directory. Like that's like it's over 10 seconds. I don't need that many. I don't need a 10-second thing. No wonder. Let's delete a bunch more images. Yeah. There you go. See that flicker there? Because it's starting over. Yeah, okay. I still wanted to, for this demonstration, like let me reduce it by half now. Let me minimize this. Take this out. Yeah. Okay, perfect. All right. Hopefully the YouTube compression will make this obvious. Let me cycle the camera. I took a quick break there just to render out that processing sketch. I rendered it out like a few seconds. And as you'll see, I rendered it to a GIF. And every few seconds, you see this sort of jarring thing happen where it goes back to the beginning. The last frame of this noisy scene doesn't match the first frame. And this is something that I talked about in previous coding challenge videos, how to get a sequence of values, a one-dimensional array of random values where the last value matches up with the first. You close that loop. And the way that I did that was I want one dimension of values. Let me walk around a circle, a circular path in a 2D noise space. So now, what we're doing is I want two-dimensional looping values. So I need to basically walk around the space of a torus, right? I need all of these values to move around and like come on back. And the way that I can do that, right? If what I wanted was one value, then all I need to do is walk around the path of like 2 dimensions. Now, what I want is, I always want one value, sorry. Let me say that again. If what I want is a one-dimensional, a single-dimensional list of values, then I'm saying the same thing again. I don't need to say that. The torus thing is fine. So So in order to do this, I just need to give it two-dimensional values. I need to give it its two-dimensional coordinate space and then its other space along the circle, a circular path. So I need 4 dimensions, right? I need the x and the y, and then I need the location along the circular path that's coming out. Somebody can hopefully make a nice diagram of this that I can link to or include someday as like an overlay here. Look at this diagram. If you make this in the next couple days, it will go here, I swear. All right, so, all right. Okay, so let's do this. So first, what I want to do is, let me just be clear, this is the processing noise 3D example, and the only thing changed is I've added this OpenSimplex Noise code from Kurt Spencer. I will link to where that code and some background about this open source implementation, where it comes from, in the video's description. And instead of calling processing's noise function, I'm calling noise.efal from Kurt Spencer's OpenSimplex Noise, and that gives me a double, so I have to convert that into a float, and it also gives me a range of values between -1 and 1, which is different than the values between 0 and 1. Okay, so what I would like to do, though, however, is make this a bit more visually obvious what's going on. So I'm going to change this. I'm going to threshold this to render the color either black or white. And one way I can do that is with a nice little ternary expression. I can say brightness equals, like, is noise greater than 0? If the noise value that comes out is greater than 0, then I want to see 255. Otherwise, I want to see 0. So if I do that, you'll see we get this. And I can kind of play with the sort of increment values, like maybe let me make the increment a little less, but make it go through the z space faster. I don't know. So now we can see. So this would be bad. I should have rendered this to a GIF so you could see it not looping, but this is what I want to have loop. And also, look at the beauty of this particular noise algorithm. It's very smooth. It doesn't feel like it's sort of, it doesn't have that directional artifact. It doesn't feel like it's sort of slowing down to a stop and then going backwards. It just keeps going with this kind of beautiful organic randomness. All right, so now that I have this, let's turn this into a GIF loop. All of these videos are now kind of this series, everything's depending on each other. So I did have a previous coding challenge where I made processing code that just renders out the frames for a GIF loop. And at the demonstration, it's just a rotating square. So what I want to do is I'm going to use that as my basis, and I'm going to grab what I need from here. So I'm going to grab all of the variables that are at the top here. You know what, pause for a second. One of the things I meant to do was also do a screen capture because it's possible that when we edit stuff back together later that having just the plain screen capture might be helpful. So let me just set that going. I meant to do this at the beginning, but obviously I forgot. But I noticed here I'm standing in front of the code, so this could be a place for that. Let me grab the, all right, so let me do that again. Let me grab all of the code before setup from here, which is all of this. I'm going to put that into my GIF loop code. Then I want to make the new OpenSimplex Noise object, and I'm going to put that in here. Now it's complaining to me it doesn't know what OpenSimplex Noise is, so I do need to make a new tab. I'm going to call it OpenSimplex Noise.java, and whoops, it needs to be .java because this particular OpenSimplex Noise class is using some features of the Java programming language that don't work super elegantly in processing. So I can then just go copy and paste it over. You know, certainly there's more streamlined ways of importing a Java class, but just copying it over is one way. Then I'm going to come back to here, and what I'm going to do is everything that's in draw is what should go into this render class, this render function. So this render function should now have all of the drawing code, and I'm going to run this now. I messed up. Oh, I'm missing one curly bracket. There we go. So this is exactly the, oh, there's so many things open here. By the way, this is for when the audio wasn't working. Hold on. You can clip this part out. All right, let me just rearrange here. I don't know why. Oh, What a mess. All right, so here now we have this running. Now it's not looping yet. I've got to figure that out. I want to give myself more frames probably. And actually, let's make it short because I really want to make sure it's looping. Let's make it 640 by 360. It's kind of nice to have that aspect ratio. Okay. So now this is what I want to render as a perfect loop. So what's going on? Okay. So here's the thing. The thing that needs to loop is the z-axis. The z-axis, instead of moving forward in time, should move around in a circular path to create that donut in three-dimensional space. So how do I do that exactly? Well, it turns out that the way that I can do that is, let me actually get rid of this idea of z offset, and I want to have let's see if I can diagram this. All right, so this is my two-dimensional plane of noise in three-dimensional space. And I'm at any given point. What I want to do is kind of walk around in a circle. If this were the flat plane, the circle would come out like this. I don't know if this is real. So what I need is an angle. I need to rotate around. I need to use that polar coordinate formula to rotate around a circular path within, that's like one plane of the three-dimensional space. So to do that, I use four-dimensional noise because what I'm doing here is remember, in looping a GIF, I want a percentage from 0 to 100%. So I can now have an angle which is equal to map that percent from 0, which goes between 0 and 1, to between 0 and 2 pi. Then I can have, I'm going to call this like U offset for the third dimension, and I'm going to call this a V offset for the fourth dimension. And so what those are is I'm going to say cosine of the angle and sine of the angle, right? So I'm going to use the polar to Cartesian coordinate transformation and map these values, which go between 0 and 1. No, sorry, go between -1 and 1 to between some noise radius, some noise diameter. This is a concept I talked about in the previous looping video, but it's very hard to type and talk at the same time. Sometimes I do a good job, sometimes I'm a mess. And right now I'm a mess because this is very hard to explain. So this is exactly the same technique that I did in the first noise loop video, where I just had an X and a Y. Now I have an X and a Y, but the looping is happening in the U and the V. So that's where the size of this circle is important. So I'm not sure whether in the OpenSimplex Noise algorithm if I can have negative values or not, but to be safe, I'm just going to map these between 0 and 2. So that's somewhat, I'm picking sort of an arbitrary, this I think we called noise diameter or something like that. I'm picking an arbitrary value. Now, down here, change this to U offset, V offset, and let's run this. Did I get everything right? No. Oh, I have an extra 0 in here because I'm going crazy. I don't have, Z offset is not a thing anymore. And here we go. Why is it running so slow? Did I turn rendering on? No. Weird. When I did this the other day, the fourth dimension didn't make it run so slow. $40 is slower. Oh, Etienne is watching. Etienne, Jacob. Hi, Etienne. Everybody say thank you, Etienne, in the chat. Applause. So maybe it just is that slow. I could have sworn, though, I did this. Oh, maybe I just automatically rendered it. Okay, so one thing to note here is that 4D, the implementation for getting 4D noise is quite slow. And you can see this frame rate sort of like chugging along. The good news for us is we're here to render out to a loop. So I don't care about the speed, the frame rate. I am just going to turn record to true, and I'm going to run this again, and I will see you when it finishes rendering. I'm loving seeing everybody say hi, Etienne. Thanks, Etienne. Thank you, Etienne. We're almost to 120 frames. That's like 4 seconds. Okay, so it finished rendering. All right, it finished rendering. So here, the good news, just to reiterate, because 3D noise worked quite smoothly, if you're not rendering out to a loop, you don't need that fourth dimension. You could just use the third dimension and watch your real-time software in your media art installation work beautifully. But if I'm rendering it out, I want to close that loop, I do need that fourth dimension. Okay, so let's now, I'm going to use the same technique where I am going to go to, I need to open up a terminal. I have FFmpeg installed. Am I in the right directory? I am going to say, no, I'm not. I need to go to my, this directory, and I'm going to say FFmpeg -f image2 dash frame rate 30 -I, and then the directory was called output GIF. There's 3 digits, %03D, .png, and then noise loop, I'll just call it noise loop, .gif. Here we go. It already exists. I must have done this before sometime. Let me overwrite it. Oh, whoa, 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 whoa. Something weird happened. I'm in the wrong directory. Shoot. Yeah, GIF loop 40. I'm totally in the wrong directory. Oh, okay. Fortunately, all right. I'm going to switch over to my terminal window, and I'm in the GIF loop 4D sketches folder, and now I'm going to use FFmpeg to render all those frames into a GIF. So I'm going to say FFmpeg -f image2, and FFmpeg is a utility you would have to install separately. I'll include a link to how to do that in this video's description. -f image2 frame rate, let's give it 30 frames per second. -I, the file path, which is output GIF. It's each file is GIF dash and then a number, so 3 digits .png, and then I'll call it noise loop.gif, and I'm going to render that out. I am going to take a look at it. Here it is. Let's take a look. And by golly, if that doesn't loop, I don't know what loops. Right? This is about 4 seconds long. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. So, of course, you can see, you might be able to detect the loop because it's so short, but if I made it a little longer and if there was a bit more, if I was more artistic and had more creative ideas about how to vary the visual quality, you might be able to create something more like what I showed you in those original Etienne Jacob GIFs. So, now, I think I need to do some more with this. Do I do it in this video? I'm trying to estimate like how long that actually was. All right. Yes, I do want to do something more. I'm just trying to decide, should it be in a separate video? I'm going to keep keep going. Q learning. If only this was Q learning. I'm so easily distracted by noise algorithms. I'm not getting the stuff I'm supposed to be doing. Oh, what's happening to my life? All right. Now, you might be thinking, oh, I've come to the end of this video. I don't need to watch any more. But there's more. What I want to look at very briefly, and it'll probably not be brief, I want to look at how to do a few more things with this. What if I want multiple parameters to loop in interesting ways? I don't know that I can actually describe what it is that I want to do. I'm just going to start coding it. So first of all, let me do something with this. I'm just going to stay in this GIF loop thing. I'm going to turn record to false. And I'm also just going to, at the moment, just comment out V off so that I can see this run much faster. So, by the way, this is what happens if you do 3 dimensions. It's looping, but you're just kind of going forward in time, then backward. A lot of people were asking, why do I need 4 dimensions? So this is what it looks like with 3 dimensions. It's got directional artifacts, I might say. It's kind of moving towards a spot, and then it's coming back to the beginning. So I could make it loop with 3 dimensions, but that's not what I want to do. I just want it to run fast right now. So what I want to do, I'm thinking. Aha. Okay. What I want to do is not render this as pixels anymore. I want to start visualizing my own geometry that I'm inventing and designing. So to do that, I think a nice way to do that would be to think of the screen as a grid of quadrants, maybe with each, and let me use an integer here, each square having a width of like 20 pixels, and then I'll need a number of columns and rows. And so I'm going to say int columns equals the width divided by w, int rows equals height divided by w. I'm going to go here, and I'm still going to have essentially this same loop, but I'm going to change it from, and let me simplify here also. Let me say for int I equals 0, I is less than number of columns. For int j equals 0, j is less than number of rows. And then I'm going to get rid of all this x offset, y offset. I'm just going to get rid of a lot of stuff. Let me comment this out. I'm going to do something incredibly simple for a second. I'm not drawing pixels. I'm not updating pixels. Well, all I want to do is I want to know x. The x location is I times w. The y location is j times w. I want to translate to xy. I'm going to use push matrix and pop matrix to make this translation only apply to this singular moment. And I'm going to draw a line from 0, 0 to w comma 0. And why do I not see anything? Something is stuck somewhere. Percent 0, render percent, record false, background 0, stroke 255. What did I miss? What am I missing here? Height divided by 2. Oh! Oops, I have a bug here. Not height divided by 2, height divided by w. So now I should be able to see these lines. No? J++. Stroke 255. What am I doing wrong here? Render's being called, percent's not being used. Ugh. Oh, I have another really bad bug. Oh, this is such a common error in processing in Java. I declared global variables cols and rows up there, and then I redeclared them here. So columns and rows are 0. So many bugs. These need to not be redeclared. Just setting them here. There we go. This is what I wanted to see. And let me just, to be clear about this, let me use random. I'm going to put a rotation here, like rotate by, actually, let me just rotate by pi divided by 8. Right, you can see these are a whole bunch of lines. So what I want to do is set the rotation according to OpenSimplex Noise. All right, so in order to do that, I now need to say, here's my noise value, and I'm going to put v off back in. And then I want to take that value, angle equals map n, which has a range between -1 and 1, to between 0 and 2 pi. And I'm going to put angle in here. And we have this. X offset, oh, and now I need to create X offset and Y offset. So X offset is map the columns, which go from 0 to columns to between like 0. And again, these should, I'm just going to go between 0 and 2. I should make these variables, right, to think about those actual offsets. And then, I have this also as an angle. Oy. Let's call this A. There we go. And let me offset it a little bit. Let me make it a little bit bigger. I already have the width as 20. That's fine. Let me, I think also what I should do is translate by w divided by 2, so that everything is centered nicely. And I should probably draw the lines from negative w divided by 2 to w divided by 2. There we go. So now look at this. This is my, oh wait, something is wrong here, because each column is identical. So I have something wrong. This needs to be J. The Y, I'm getting everything wrong all of a sudden. Take a deep breath, everybody. I'm trying to rush this. There's no need to rush. We're going to be here for a while. You run this. There we go. This is what I'm looking for. This is now OpenSimplex Noise. What I'm showing you is I can map this onto geometry. Boy, I really should make a nice terrain, right? That's coming. So I can map this onto geometry. Now, here's the thing. What if what I want is different noise values? Sorry, I'm looking at the chat. The chat is giving me corrections, but it's behind me in time. Oh, shoot. I got to stop doing this. I'm thinking here. I don't want to use a different noise seed, or do I? I do. Okay, so I'm thinking this is tricky. Yeah, okay, sorry. Yeah, okay. Okay. So what I think would make this more visually interesting is right now I'm only varying one parameter. I'm just varying the rotation of each line at each spot in two-dimensional space. But what if I wanted to vary like a color also, or the thickness of the line? You know, obviously drawing everything in a perfect grid, what if I wanted to draw things not in a perfect grid? That I think I'm going to let you explore. I need multiple two-dimensional noise space loops. Blah. So what I did previously to do this was create a class called a noise loop class. I'm going to do that again. So let me create a noise loop class. Oh, this is going to be hard to think. What needs to go in here? Well, what it needs is its own noise space. Sorry. So basically the idea is that if I create a new noise loop, I create a new noise space, and what I can do is I can give it a seed. So I'm going to say int seed equals int random. Again, I'm just going to pick some arbitrary range between like 0 and 10,000. I could be more thoughtful about like sort of the maximum integer range or something. But now what I'm doing is I'm having multiple simplex noise generators, each with a different seed. This is slightly different than what I did in my previous, in the previous coding challenge, where I used a different part of the same noise space. But here I'm using a different seed. So now what I should be able to do is I'm just going to write, there's a variety of ways I can do this, but right now let me just put an eval function in this. And this is kind of silly. I don't necessarily need to wrap OpenSimplexNoise into a separate class, because I could just make a bunch of instances of it. I think, you know what, let's just do it that way. I think there's going to be some benefit to wrapping it into a class, but just to demonstrate this idea, I could do this, right? Although I might want to have different diameter spaces. No, let's wrap. I'm very conflicted here. Yes, I'm going to wrap it into a class. Because the reason why I want to do that is I also want to have a variable that's that diameter, the diameter of the torus, basically. And that's something that I want to be able to set when I create the noise loop. So in other words, and then I have an eval function in which I would get x offset, y offset, z, and then an angle. And I would do exactly, there's more that I could, and then I would take this right here. Is this what I'm looking for? Yes. And then I would also give it a minimum and a maximum. And so let me give it minimum and maximum. And I'm using some weird variable naming here, but that's just what I'm doing right now. Because that way, and I think I want to like store the x offset and y, I'll calculate that in here somewhere, but I haven't figured out how to do that just yet. So, and now what I need, thank you very much, is I need this calculation to happen in here. And then this is now between, you know what, I only need the maximum. No, oh, no. This is between 0 and the diameter. And then I'm returning map the noise result, which goes between z negative 1 and 1, to minimum and maximum. So let me just recreate, using this, I've encapsulated all of the ideas of the noise loop into my own class that has its own seeded OpenSimplex Noise object. So now, if I've done everything correctly, this I don't need anymore. I'm going to create a noise loop. I'm going to call it like loop 1. And in setup, I'm going to say loop 1 equals a new noise loop. What do I need to create the noise loop? I want to know the diameter, 2, and the minimum and maximum, 0 and 2 pi. And then down here, I'm saying float A equals a loop 1.eval x offset, y offset, and angle. So this should be exactly what I had before. No, oh, and these have to say float. In Java, you have to type everything, and I'm just data type everything, and I'm forgetting that. I'm forgetting that again here, because I'm so used to JavaScript these days. And and this is not a void function. This returns a float, speaking of typing things. All right, so this is the same as what I had before, right? The difference is I am now taking that angle and passing it to my noise loop function. I guess, I guess I really need to give it, that noise loop needs the X and Y offset outside. I'm going to keep that here. So in theory, what I can do now, just bear with me, I don't know that I've explained this super well, I might need to come back to it at the end, is I can create a second noise loop. Whoops. Let me do like for color. I'm going to do two. Like let me call this like R loop and G loop or B loop. What I can do is I can create two more. And I can, sorry, this is what I should be. So I have R loop and G loop, and this should really be D loop for diameter maybe. No, A loop for the angle of rotation. I don't know. And these should go between 0 and 255. Maybe I want to give them like a larger diameter. And now what I can do is I could say, let me also draw a rectangle. Separately, like let me say rectangle 0, 0, width. This is really a square. Let me just see what happens if I just add something that's white here with some alpha. G loop. Oh, G loop. B loop. B loop. This is now A loop. Oh, the squares are off because of the way that I centered everything. That's no problem. Let me say rect mode center. Great. So now I'm going to also say here no stroke. Let me draw the, I don't know, I should just make the line colored. I don't know why I'm drawing a background. But the point is I'm just showing you the possibilities. Now, if you will indulge me for a second, I can now also say float R equals this. I can get the looping values R and B, and I can put those into here. R, R, comma 100, comma B, to get some colors and give it a little more. So now, okay, so why is that not changing very much? So what did I miss? Oh, people in the chat are saying he's tired. I think that's true. Right. This should probably be its own separate video. But anyway, oops, people in the chat are saying that I'm tired, which clearly I am. I'm not paying attention to lots of things I'm doing. This should be R loop, B loop. There we go. Whoa, that's all happening way too fast. So let me make the diameter much less. I want these colors to be a little bit brighter. So let me make the minimum 100. All right. So you can see now, now the color is changing. I could make another loop for the thickness. In a way, I kind of want to like not draw the lines anymore because I'm just curious about this color. Yeah, so that's kind of interesting. You can see, I mean, this really is just another way. All of these are kind of the same, but it might have been more interesting to vary the thickness of the line. So let me just try that if you will indulge me for a little bit longer. So I'm going to say like S loop, which I'll also use 2 and goes between like stroke weight of 1 and stroke weight of 6. Let's put the line back and let's say, I'm going to say stroke weight is the S loop, evaluate, and then I'm going to say stroke weight, SW. And then I need to also declare it up here. I need another S loop. That's kind of interesting. Oh, I should make it like this, the length of it. There's so many possibilities here. Oh, this is terrible. But I think actually what I would like is for it to be much thicker. Yeah, so that's kind of interesting. Anyway, you see the point. I should make that the color. Hold on. Let's get rid of let's at least try to finish with something and then render it to a GIF. Please, please, let me get somewhere with this. So I'm going to take this out and I'm going to say stroke R100, R50B 200. Whoa, where is, oh, I still have the square in there. There we go. I don't know what I've done. It looks, I don't like this at all. I mean, I'm demonstrating the idea. It's so fast. All right. Let me try giving it some more frames to work with so that I can slow down. And there we go. I don't claim to have made anything of any particular visual magic here. I like the first one that I made better, frankly. I think I should just end the video there. I should have just ended the video where I started. I think maybe we won't include this digression. I'll just go to the terrain. I think that makes more sense. So I think this can end unless I can think of, oh, but I do like the idea of demonstrating how you can have multiple noise loops in a separate class. Maybe this is nicer than I think. I just can't see the beauty in it. Spectral piano, right? It's really hard to follow because you're using 4 loops. ES6 inheritance. How many people are desperate for the ES6 inheritance? Because I'm going to do that. I should make them thicker. What would have been interesting, I think, would, okay, let's try that. All right, let's just, give me a minute to like play. Let's make them, oh, like what if I actually though like let it go all the way down? Oh yeah, that's kind of more interesting. And let's let the color have a bit more change to it. Oh, you know what would actually be a different way of experimenting with this would actually be to go over a larger space in the 2D direction. There we go. Ah, this is what I was like looking to do. I knew I was missing something all along. Yeah. Okay. Oh, good. This wasn't all for naught. This wasn't all for naught. Ah, this is what I was missing. Okay, hold on. Let me back up here. All right, I'm not very happy. I'm not very happy with this visual result right now. And I just suddenly, bing, realized what's wrong here. What I actually am looking at here, what I left to be really, really small, I was so focused on my torus loop that I forgot to think about the fact that I also have this 2-dimensional space. And I am actually looking at a very small section of it, and so the values are so similar to each other. And where is that happening in the code? That's actually happening here. Before I had like an increment value that I was playing with, and instead of having an increment value, I'm just mapping between 0 and 2. I'm looking in the, whoops. I'm looking in the 2-dimensional space between 0 and 2. And if I just were to expand that out, I'm going to have more variety, I think, and I'm going to see a more interesting pattern. So let's do that. So let's change a few things. Number one is, where am I here? Let's look at the values I have up here. So this is all fine. Let's actually let's actually have quite a bit more variety of thicknesses. And maybe we can also like ramp these up a little bit. But really, this I think is going to be the key. So let me look from 0 instead of to 2 to 0 to 10. There we go. And so now, this is more like what I was kind of imagining we might get. This is a scene, and it's actually looping. Let me give it, in a way, I kind of want to like take out the loop to let it, 360 is good. So I think this is good. Let me give it I'll give it the full range of color, and let me actually set this back down to 0. Maybe those are too thick. I got to stop playing with this. There we go. Okay, I like this. Whatever. Here we go. This is my 4-dimensional 2D OpenSimplex Noise loop, and now it's time to render this as a GIF. Why not, right? So I am going to, all I have to do is change record to true, hit run, wait a little bit, see you in a few minutes. In the chat, Espen Larson. Oh, Yolaxi says I made the MIDI. Oh, it stopped. I made the MIDI version of Polar Cartesian. All right, it has rendered. Now I should be able to just run ffmpeg again. I'm going to overwrite my previous GIF. No, I don't want to overwrite it. Let's keep my previous GIF, noise loop 2. Let's render that out. And this video has come to a close. Let's take a look. This was our first noise looping GIF, and now we have a new one. There it is. Can you find the loop? Can you detect the loop? Now, I think, so here's the thing. So, okay. Do this again. Let me find my looping GIF. There it is. By the way, this is my previous one. Here's this one. Oh, I should really just, and let me open it up, preview it here, and there we go. So this is now complete. This is OpenSimplex Noise in a 2-dimensional space. Different parameters of each element being drawn are controlled by different seeded OpenSimplex Noise spaces, each of which is looping over this like torus. Ah! So I'm excited to see what you might make from this. But I think, I'm excited to see what you might make from this. And I think one thing that is missing from what I've done here is I am locking myself to the 2-dimensional grid. And if you look at Etienne Jacob's work, you'll see that there is a kind of ingenuity and creativity to how the 2-dimensional space is drawn and where things are placed. So this is instill a kind of literal visualization of the noise data, and I'm just, I have some different parameters that I'm trying, but I think you could go further with this, and you could think about what it is you're drawing in this space. In addition, and I would definitely like to do this, you could do this with a terrain. And I do have a coding challenge, Perlin Noise Terrain, which uses Perlin Noise Classic, which you can now try with OpenSimplex Noise and see what kind of visual quality it has, as well as make it a loop. So thank you for watching. If you made it all the way to this video, at the end of this video, I am quite impressed, and I'm really thrilled, and I really just can't thank you enough for sticking with me with this. And there you go. So Rory O'Connor writes, if you want a perfect loop, just reverse it end to end. So yes, that is true. It would loop, but it would have a particular visual quality to it where you would see it suddenly come to a stopping point and then reverse direction. I suppose it's possible you could design it in such a way that that's not detectable, but this is a smoother way to be able to achieve that effect. All right. All right. Mathieu, I don't know how you're going to make anything you're gonna make a mole. If you can make, that was a mountain of mess. If you can make a molehill out of it, go in reverse, or make a mountain out of a molehill. Maybe that was a molehill. Is a molehill a mess? I don't understand how this expression works. It's 12:30. A very ill-advised plan would be for me to do my inheritance tutorial now, but I do have a little bit more time, and I'm going to do that. I'm not going to look at the terrain, unfortunately. Okay. Oops. I just want to look at this, by the way, with, never mind. And so let me quit this. And let me exit out of here. P5 web editor. Where did I do the inheritance stuff? Prototype discussion. I did it here. Okay, let's do it with, I'm going to take a short break just to get some water. Let me get this set up, okay? Maybe I'll try to, Yolaxi, is the MIDI version easy for me to find? Because I will play it while I take a short break. I got to fix my shell. I will get to that eventually. I'm too tired to explain what I'm doing right now. I'm just getting myself ready. Coffee. I probably should get some coffee. I could get coffee, but you'd be waiting a lot more than just a few minutes, which is what it'll take me to get water. Okay. It's very quiet. It's weird. It's ominously quiet. Okay, I'm ready, I think. Maybe I missed something. Yeah, not yet. Okay, yeah, let's be a little more. Okay. All right. I am ready. I am ready. Yep. All right. I didn't see, where's that MIDI file? Let's see, MIDI polar to Cartesian. Oh, here we go. Download. Okay, I'll download this another. Okay. Oh, you can't hear this. Or maybe you can't hear this because it's coming through my microphone. I got to learn how to play this. I love it so much. I love it so much. I have to get some water. I have to change settings to get the output of the laptop onto, and I can like download it. I'll have to be able to play that. Once I get it on the soundboard, I can play it. I'll just have to play the actual one. I'm going to mute my mic. I'm going to put it onto the wallpaper. You can still hear me. You can hear it because it's coming through my mic. Well, this song's not long enough for me to get water. All right, I'll be back. I need a waiting animation. All right, I am back. Oh, shoot. This song goes on forever. I'm just waiting for that part at the end. Oh, I was trying to time my cha-cha-cha, cha-cha-cha. Okay. Oh, am I on live streaming right now? Oh, I forgot. All right. Okay. Okay. All right. Okay. Cycle the camera. I don't know if I just did this. All right, I'm going to give myself till 1:30. I mean, I would love to be done before then, but that's kind of my limit. That's my definite limit. Okay. All right. I am here in this video to talk to you about something called inheritance. Inheritance in the context of object-oriented programming and JavaScript and ES6 classes. Whew. So first of all, there are three core foundational principles to object-oriented programming. Let me write those down. There's this idea of encapsulation. There is this idea of inheritance. That is the topic of this particular video. And there is also the concept of polymorphism, which I will come back to. And I have made videos on all of these topics before. I can link to them. Those videos, however, were all made in the processing programming environment and looking at these three principles and the Java programming language. Now I am talking about exactly the same thing, but in JavaScript. And I have already made a whole set of videos about encapsulation and object-oriented programming in JavaScript, making use of something called ES6 classes. So one of the things you have to get used to if you choose to spend your life programming in JavaScript is that it's just always changing and there's 500 different ways to do the same thing and everybody's got their opinion on which way is best. And a lot of my older videos used a prototypical object-based way of doing object-oriented programming with a constructor function, and you'll find those in older coding challenges, and you'll even find a set of videos about how to do object-oriented programming that way, and even one about how to do inheritance that way. And if you watch that, you're a true champion because this is wildly confusing and I have no idea if I explained that well. But I'm here in this video to talk about ES6 classes. So what is a class? Sorry, ES6 being the version of JavaScript that came out in 2015. It is currently 2019 while I'm recording this. But it is now pretty widely supported across all browsers. You know, you have to look up the exact specifications, but I think we can feel pretty comfortable using it. So the idea of a class, and I'm going to use as my example something called particle, because I am demonstrating this in the context of animation and graphics. So I'm drawing particles in a canvas. Those particles move around the canvas, and the class is a template for the making of an object. If I create a particle class, then I can have a variable somewhere else. Maybe I call it P, and I can say new particle. A metaphor, analogy that's often used for, is it a metaphor or analogy? I'm going to say cookie cutter. I think that's really an analogy. Yeah. An analogy that's often used to describe the distinction between the class and the object is the cookie cutter versus the cookie. So the cookie cutter isn't actually a cookie. It's a thing that you can make cookies with. So this is a template. There's no particle object here. This is just a template to make actual particle objects. And if I have my template, I can make more than one particle object, each with its own set of properties, all made from the same template. So the new keyword here, saying new particle, means execute something inside the class called a constructor function. So I guess I'm by accident reviewing some of the basics of ES6 classes and object-oriented programming to get myself into the inheritance topic. But I'm gonna kind of move along because you can find and see many more details and examples about this in the other videos. So this is the basic idea. So let's go over to the code for a second. And what I have in this, if I refresh, I've got this little dot moving around. And what I want to do is I'm going to look at the, time out for a second. My upper text is out of frame. Let's see how bad that was. Oh, that's weird. What's out of frame? Because I see it all in my preview. What's out of frame? Don't use the word template for ES6. Oh, I did something wrong. What's out of frame? I don't see anything out of frame. Let me look on my preview over here. Oh, I don't know. Oh, welcome new member, Jordy Vanderbolt. Oh, so weird. Because what I see, this is so weird. Hold on, let me look at the live stream here. View on watch page. No, I see it not out of frame. Nothing is out of frame. Okay. I think maybe, K. Weekman, you've scrolled up or something. You've scrolled on your screen because it's all in frame. Okay. I've written porticle. Yes. Okay. Somebody has their YouTube window scrolled. Crisis averted. What was I doing? It's coming over here. Okay, I forgot what I was doing, but this is good. Okay. There's a little thing. It's particle anyway. All right. So what I have over here in my sketch is a single particle moving around the canvas. Oh wait, time out. Why was I not supposed to say template? A class is a blueprint. Wait, hold on. Blueprint. I'm being trolled. No, it's not for ES6. It's for a class, which is correct. A class is a blueprint. Okay. All right. I'm gonna keep that. All right. Whoops. All right. So all right. So what I have over here is a canvas with a little dot moving around. And this dot is an example of a particle object. So here's my class. I have the constructor. The object gets an x and a y. And the update function changes the x and y randomly. And the show function draws it as a point. A point. This is what happens when you live stream for like 2.5 hours. Draws it as a point. It would be great if there was a function called point, by the way. Anyway. So let's say now, let's say this is your life. This is what's happening to you. You know what I would like? I would like to put another one of these particles. But I want it to look different. And so I want it to be a square particle. So the first thing you might do is like, okay, I'm going to make a Boolean variable like is square, and I'm going to set that to a square. I'm going to add another argument here, square, and then I'm going to say, all right, if this dot is square, then draw this as a, not is square a function, then just use rectangle, this dot x, this dot y, when will this ever end? At least I could use the square function, it's the least I could do. Could say square, otherwise make it a point, and then, I'm so tired already, and then I can go over here to, why is it, what? Why is it not? Oh, I need a parentheses here, and then I have to go over here, and I could change this to true because I want it to be a square, and then I refresh and look, it's a square, and then I could say false, and it's not. So now I could have two particles. I could have P1 and P2, and I could have P1 do this, and P2 do this. I'm so tired. This is so much work and so much coding. I'm going to call update and show on both of those, and there we go. Now I have my circle and my square. All right, so that's one solution to this. I have two different, mostly the same things with some sort of core essential difference. I don't like this solution. Let me do it another way. I'm going to just create a new JavaScript file. I'm going to call it square.js. I'm going to go here. I'm going to copy, paste the whole thing, paste that in here. I'm going to get rid of this idea of is square, and I'm going to have a class called square p for square particle. I'm going to get rid of this variable, and then I'm going to, this one's the square, so I'm going to draw it as a square. And then this one is the circle, so I'm going to draw this just as a plain old point, and I don't need this anymore, and I don't need this. So I have basically a particle class, and I have a square class, square p class. They're entirely the same, but one draws as a square, and one draws as a particle. Now I'm going to go back to sketch.js, and I'm going to say new square p, and I'm going to refresh. And if I did everything right, no, square p is not defined because I forgot to reference it in my index.html. So let me do that. Then I'm going to go back. And there we go. Good night. This video is now over, but not at all. In fact, I'm only just getting started. All of this was exposition. Exposition to the point where we are right now, where we think to ourselves, there has got to be a better way. There has got to be a better way than having some kind of like type variable inside of my class, and then I use if statements, or to have two separate classes which I've just copy pasted the code and changed some things. How could I have this idea of classes that inherit a bunch of properties from another class but modify them? And this is in fact what inheritance is for. So there are lots of examples of this, and inheritance, the way you might design your software, inheritance kind of operates in a tree-like structure. So maybe I'll come back to that. So let's, I don't know what I'm saying. I was going to go off on, I don't know what's going on. I should not look at the chat. I should not look at the chat. Do not look at the chat. Or look at the chat. I don't look at the chat. So let's now think about that in the context of this. What if I could write another class, and I'm going to call that class square p, which is like the silliest name for a class ever, but it's somehow my example for this video. So what happens when you record a tutorial after 3 hours of recording tutorials? Class square p. But I missed the most important piece of this. You had to wait through like so much video just to get to this point, where now I am going to say extends, and this is the most important thing, particle. This is the keyword. Extends is a keyword in JavaScript in ES6 that makes the square particle class, the square p class, inherit from particle. So let's think about what this is. Now the constructor is a special case. The constructor is a special case, so we're going to have to work with it in a different way. But If what this means is if there is an update function, and if there is a show function, that it's as if I copy pasted the update and the show function into square P, but I don't actually have to. These functions are now part of the square P class. It extends from particle, it inherits particle. This is also sometimes referred to as the child class, or maybe the subclass. I'm getting close to the top, I know. And this is often referred to as the superclass or the parent class. And the word super is quite important here because that's actually a key word, a key word in JavaScript that's going to allow us to do some interesting things later in a moment. All right, so now I said the constructor was a special case. You really always have to write your own constructor. So no matter what, even if I want to make this square P an exact replica of particle, I still have to write the constructor here. And then I could put my own code in here, but in a lot of cases, what I want to do is actually say particle.call this. This is really weird syntax, but essentially what this is doing is it's saying, hey, you know what I want to do when I create a square P particle? What I want to do is do everything that I do in the particle, but to this object. And that's essentially calling the particle's constructor. So let's go do that right now. So I'm coming over here, and what I'm going to do now is I'm just going to have square P extends particle. I now don't need to include these here. And instead of having this code here, I can say particle.call this. I need to do something with the xy's, don't I? Let's call it confetti. I know, I used confetti somewhere else. Wait, this is right? Hold on, let me just see. Yeah, no, that's not right. What did I miss here? Do I say this, x, like this? No. What am I forgetting? I guess I'll look at my examples. Where are my examples? Nature of code. I've done this so many times recently. I don't know why I'm blanking on this right now. Systems, inheritance, confetti. Ugh, I didn't even do it in here. You don't have to. What is wrong with me? What am I losing? I'm losing my mind. Super XY, yeah. But, oh, I'm totally wrong. Oh. Hold on, let me be sure about this. Because I was doing this in class yesterday. I think I'm just remembering the prototype thing. Let me just be sure about this. Let me find my sketch from class here. NYU, inheritance demo. Square. Yeah, super. Prototype. Prototypical inheritance, you got me again. Oh. All right. I have done something quite wrong. I spent this whole time explaining that there's this thing called ES6, I guess I erased that, which means I don't have to use the old prototype way in JavaScript, and yet I just did that by accident. This is from the old way. What is wrong with me? I spent some time explaining to you why this can be referred to as the superclass and why that keyword is important. It's because, maybe I should just redo that part of the video, or is it interesting? It's not really interesting to have this mistake in there. I don't remember where I said that though. Yeah, I think it's not interesting to have that mistake in there. So, let's see if anybody can remember. Did I, yeah. Super is called. I know. Everybody's telling me this. Here's my question for you. If anybody can remember the last 15 minutes of your life watching this, did I reference super and parent and child and sub after I wrote particle.call this? Or did I write particle.call this and then talk about that? Because if the last thing I did was just write particle.call this, I can just do that again. I will give the chat a second to catch up. It is 1 o'clock. Maybe I can scroll back. Yeah, I mean, Mark Powell writes it is interesting to have a mistake. I agree it's interesting to have this mistake in the live stream, but the edited videos, and sometimes it's useful in the coding challenges to have mistakes, but I feel like sometimes the people who come to find the videos later are just looking to learn how it works, and an extra 5 minutes of getting it wrong is confusing. First came before super. Okay. Yeah. After talking about sub-superclass. That's what Nathan is saying. But people in the chat are telling me super before. Oh, that's the same thing. Excellent. Okay. So let's see if Mathieu can work his magic. And I'm just going to go from where I wrote. But where did I write constructor? I don't know. We'll try something. All right. So I think what I did, so actually weirdly I think it might work without me explicitly calling super. And but I think it's bad, that's bad, kind of bad practice. Now, while I could be done by just inheriting update and show and like sort of assuming I'm also going to inherit the constructor, it's a good habit, and I think in almost all cases you really need to explicitly write your own constructor even if you are extending another class. But in the case where all I want to do is when I make a square p, a square particle, and actually in my nature of code book, which this example is mostly the same, I call this class confetti. That's another name I could be using. Is I want to just say, you know what, I'm going to define my own constructor, but I want to do exactly the same thing as whatever happens in here. And the way to do that is just by calling the super function. So the keyword super means execute something from the parent or super class. So super with parentheses means run the constructor. So let's now actually try to go over and do this in the code. So hold on, I have to back up here. I just realized. Okay. All right, so now what we can do is we can say square p extends particle. This is the magic. Once I've extended particle, I can just get rid of this. That stuff is all inherited now from particle. Woohoo! And then I can just say, hey, super, do the same thing. And I still have to pass in those arguments. This is basically saying, hey, you're making a new square p. When you make a new square p, go ahead and call the particle the code that's in the particle constructor. So this is now the square particle. Let's call this confetti, just as like a different name. Now if I go back to the sketch, and this was left over from before, I forgot that I had this in there, right? If I run this again, we have two identical particles. It's as if I made two particles because the confetti class, the confetti object, is a complete duplicate. It just inherits the particle class completely. But the whole point of this is we can now do things like augment and override. So what if I want my confetti objects to always have a color? So maybe I could add another value here. Like I'm going to call this dot brightness, or this dot bright equals a random number between 0 and 255. So confetti objects do everything a particle does, but get an additional property. And then maybe, they don't actually, I want to draw them a different way. I want their physics to be exactly the same, so I want to inherit the update function, but I want to draw them a different way. So I can actually override the show function. So if I write a function that has the same name of the function that it's inheriting, then this will then be ignored for any confetti objects. And just to change that name here, let me call this confetti. So let's do that. Let's augment and override. I mean, those are sort of terms, I don't know what the technical terms for those things are. So back over here, I might say something like, all right, so initialize x and y the same way, but add a new property that's a random number between 0 and 255. Then override the show function. I could go back and be like, well, how did I do this in, no, but I don't need to. I don't even need to. I'm just going to say, in the show function, I'm going to say fill this dot bright, stroke 255, stroke weight 1, and then I'm going to say square this dot x, this dot y, and maybe this should also have a variable called r for like the side length, and I'm going to make that 10, and then I'm going to say this dot r. So now, if I run this, we can see, look, there is a square, there's a confetti particle, and a regular particle. So this is the magic here. And listen, you can do, okay, what have I shown you so far? This is the idea of inheritance. I can have a base class, or I can have a parent class. I can inherit from it. I can add properties, and I can override. But guess what I could also do? Let's say what I want to do is, my confetti object, it should update just like a particle updates, but I also want to do one thing more. I want its size to change. So if I come back to here, one thing I could do is in the confetti object, I could say update, and then I could say, well, first do whatever you do in the parent object. Call super.update. So do whatever you would normally do for updating, and then do one more thing. This dot r plus equal, random value. So in addition to, changing the, and that's going to be too much. In addition to changing the x and y, which presumably is taken care of by what it's inherited, also change r. And now, there we go. You can see that this is now having an additional behavior. The size is changing as it's moving. Now, I don't know that the way that I've set this up is particularly elegant or useful, but what I will say is a common technique, especially, and you'll see this in some of my videos where I work with physics libraries, is that you might have kind of like this base class that includes all of the code and math for the physics of how something moves, but and you could imagine that being a particle class. But you have all these different variations of that with slightly different behaviors and different design elements, so that base class can kind of be the core physics of your system, but lots of different things can exist in your system and be customized in ways without having to duplicate code over and over again. I should also mention that classes can only inherit from one other class, but it is called a tree, an inheritance tree. Because, and an example that I think I've given before in other videos is an animal kingdom. So you could imagine a scenario where you have this idea of an animal class, right? And maybe that has some properties that all animals share. I don't know what this would be. Weight. That's all I can think of. But then you might have, from that, you might have some like mammal, a mammal class, a reptile class. Those would have things specific to that, and then maybe the mammal from that is going to like inherit. There's going to be a canine class. I don't know if this is right biologically or what, but the point is you can inherit things all the way up the tree. So if animal has a property called weight, and mammal has a property like fur color, then canine is going to get fur color and weight. It's going to inherit that. Everything inherits. So you can have, it's not a network, it's a tree. And so this is something that's really quite powerful in designing large software systems and working with other JavaScript libraries that you want to have a very flexible and agile way of augmenting and using features from something else while implementing your own thing. This is kind of the core principle of object-oriented programming. Of inheritance. So I need to come back and I need to do one more video to talk about one other thing, which is the term polymorphism, which for me feels a little less relevant in JavaScript because polymorphism really comes up when you have a strongly typed language, because how you specify what data types certain things are. JavaScript is very good at just kind of figuring it out in lots of cases. But in this case, what I can do is I can make an array that's full of lots of different kinds of objects that inherit from each other, and then just blanket apply the same thing, the same functions, the same functionality to all of them. So maybe I'll try to do one more video just to basically take this and put it into an array. All right, thanks. I hope you got something from this. There's probably a lot more that you can do, but this maybe gives you an inkling of how inheritance works and might change the way you think about making a project in JavaScript in the future. Thanks. All right. All right. So, I don't know, the polymorphism thing is kind of, let me think about this. I got 15 minutes. I mean, this is like a 5-minute video to mention polymorphism. Polymorphism. I mean, what polymorphism means to me is it's the idea, in Java, for example, this is why it's polymorphism. Let me talk this through for a second. I could say particle P, and this is Java, equals new confetti. And this is the core idea of polymorphism in that I can treat an object in multiple forms, like I can declare it as a particle, but it's actually a confetti, and then even if I call p.update, it'll know the proper update function to call, which is the one from confetti. And this makes it easy to pull a lot of stuff out of an array, and but it doesn't. Sorry, someone was saying no sound in the chat. That doesn't really apply in the same way in JavaScript, because you're just doing this or this. So I'm trying to think, is there a salient point here that I'm missing about the idea of polymorphism? Okay, let's see what's. I'm reading this Stack Overflow post. Well, this is so old. Yeah. Yeah. I mean, no one's telling me anything that I don't already. Let's see. is the ability to react differently depending on the object type. Yeah. I guess putting it in an array is kind of because they're all... I mean, one of the great article that I love is How My Dog Learned Polymorphism. I remember reading this like years ago. And this is what I'm saying. You can do this, but this is irrelevant in JavaScript. So I don't know. Yeah, that's what I was going to do. Ruben writes, you could generate an array filling it random with particles and confetti and iterate the list calling show on each. So that's what I was going to do, but I don't really, it kind of doesn't get at polymorphism the same way, but I guess that's what I'm going to do. I'm going to just explain, I'm going to cop to it and explain exactly what I'm talking about. Okay. Let me cycle these cameras. Just Google ES6 polymorphism. That's what I just did. But nothing that answered my question came up. I'll do it one more time. I'm gonna explain it in my own way. Overloading is polymorphism. Yeah. So that's really what, in essence, the polymorph. I mean, I think that's an oversimplification, if I might be so respectfully, but yeah, all right. I wish I hadn't erased this. Okay. All right. So give me a second here. All right. I guess I just did that. I'm going to do it again. Oh, why do I always like cycle the camera and then the cable like wiggles loose? Okay. I've got one more topic here about object-oriented programming in ES6 with classes, and that is, what is polymorphism? And what does polymorphism mean, and how is it applied in JavaScript? So just to review, the core idea of object-oriented programming, creating a blueprint, a template as a class that encapsulates a whole bunch of data and functionality together, that is the idea of encapsulation. It's a little package of an object with data and functionality. Inheritance is the idea of once I've made a class and I want a class to inherit a lot of properties or functions, but modified with its own custom stuff. That's the idea of inheritance. And inheritance is a thing that happens in a tree because you can have something inherit something which inherits something else. And actually, at the end of this video, I'm going to do a little bonus. I want to just show one little trick about inheritance that might be kind of interesting. Now, what is polymorphism? So polymorphism, if we look at the word itself, poly meaning many, and morphism, morph for like form, means we can treat an element, an object that has a particular type, like a confetti object, as either a confetti object or a particle object, depending on what's convenient for us. And yet somehow the system, the compiler, the interpreter, the executor of the code is going to know what to do correctly. And so if I were in a strongly typed language, which JavaScript is not, what strongly typed, I mean you have to declare the type of a thing before you make a variable, I would have to say something. I could say, normally I would say like confetti C equals a new confetti object. This is the way in a strongly typed language I would declare a variable C, I would give it a type, it's confetti, and I'd call the confetti constructor to make that object. In a strongly typed language, I could also say particle P or particle C, whatever it is, equals new confetti. And this would be allowed because confetti extends particle. So in that case, I could consider this variable to be of different forms. I can consider it to be a particle when it's convenient or a confetti object when it's convenient. But the compiler will always know to execute and use the properties and functions of the confetti class. And this is especially convenient when you want to put a lot of stuff into an array in a strongly typed language because you don't want to keep track of which type which things are. We can basically do the same idea in JavaScript. It will just look less fantastic because JavaScript is so flexible anyway about types. But this is the core idea. So let's actually go and do this. Let's, over here, let's change. This is code from my previous video about inheritance. Let's change this to an array. And I'm going to make an array called particles. And I'm going to put a little for loop to just add 10 particles in setup. Then I'm going to say, just to get started, I'm going to say particles index I is a new particle, and I'll just put them all in the center, whatever. And then now I can say for let P of particles, and I can say, and this is a for of loop, which lets me go through every particle. I could use a for each loop. I know a lot of people prefer those. But let P of update and show. So now I should see if I refresh this, I should see, here we go, I've got 10 particles moving around. Now, what if what I wanted to do was say, if random1 is less than 0.5? So I basically want to give a 50% chance of either putting a particle object or a confetti object. The magic of all of this is that I don't have to change this code down here. I just fill this same array with a bunch of different objects. As long as they're kind of linked through this idea of inheritance, they all have an update function, they all have a show function. Polymorphism says this variable P is going to know for each one, it's going to know whether it's a confetti or a particle object, and it's going to execute the right version of the function. So we should now see we have a bunch of particles and a bunch of confetti. And every time I refresh this, there's a different random amount. So that's polymorphism. Wow, I made a kind of a short video. Time out for a second. Somebody's telling me strongly typed or explicit typing. Strongly typed or explicit typing. That's different. Strongly typed versus explicitly. Explicitly typed? I don't know. I think I should use strongly typed correctly. Is Java a strongly typed language? Python is a dynamically typed language, statically typed language. In a weakly typed language, both Java. Well, look, according to my Google search, Java is a strongly typed language. So I think I'm okay there. I think I'm okay. So Tim says, the coding train, you are confusing strong typing and explicit typing. I don't know. Let's look at this answer. Java is a strongly typed programming language. Yeah, Simon's asking about the inheritance trick. Yes, I'm going to come up with that. Strong typing and I'm gonna assume I'm okay. I'm gonna move on. I'll come back and correct that later if I need to. I didn't talk about Python, so that's okay. Is Python strongly typed? Dynamically typed? Java statically typed? Oh, so confusing. Explicit versus implicit, strongly versus weakly. Okay. I think I'm close enough, right? You know, for learning purposes, that's maybe a detail. All right. So I promised a little extra tidbit here. So one of the things I would like to show you that's useful, and this relates to actually how the toxic libs library work. Oh, no, that's not important. Okay. So I promised a little extra tidbit here at the end of this video. So one of the things that's really interesting about inheritance and that inheritance tree is that inheritance is not just the thing that's useful because you designed your own particle class and now you're designing your own confetti class that extends particle. Maybe somebody else designed something and you want to inherit everything from that. For example, there is a thing in P5 called P5 vector. I've used it in a lot of coding challenges and videos. P5 vector object is a vector object. It has an X, a Y, and a Z component and has a lot of functionality for vector math. So what I actually could do here is I could say, look at this. I could say class particle extends P5.vector. So in that case, now I'm just going to say super XY. Like I don't need to, this is now an object that's going to get X and Y from the parent class, but I don't actually, I can now start to use other stuff. So for example, my particle might also have a velocity, which is, I'm going to just make that, which is like create vector 0, comma, I want to make it random, so I'm actually going to use the P5 vector from angle, random 2D function. So it could have a random velocity, and then I can say, oh, this is so crazy, but this dot add this dot velocity, because there's an add function, and I want to add the velocity to this object because it is a P5 vector, and then I could just draw it at this at X and Y. Let's see if this works. Amazingly, this works. So this might, the behavior is very different because it's not a different random velocity, it's just a random direction. But you can see this is very powerful. Particle extended P5 vector, I suddenly got access to all of the vector math that's in P5 vector. And then confetti extends particle, so it's also a vector. And let's just look, I think it's would be useful for me to very briefly, before I go, just go over to the console and do something like let P equal a new particle. Let's just look at this. Look at this. I want to take a look at this. You can see that this is now, this particle object has an X, Y, and Z, and this is actually how it works underneath the hood. You can see here that its prototype, where it inherits everything from, is from this particular object. And if I looked at a confetti object, this has to do with the prototype stuff. This is what ES6 classes completely hides from you. And if I look at this object now, we can see, look, it has the brightness in R, it has this velocity, it has an X, Y, Z. Its prototype, what it inherits from, is particle, and that prototype is vector. So you can actually see, this is generally a place you kind of don't want to look because it's like super confusing, but you can see the inheritance chain, the prototype chain, or the inheritance tree here. Confetti extends particle, which extends vector. And this s.vector is like a weird notation because of the way the P5 library works. All right, so that was a little extra trick. You can think about that. Maybe that would confuse you. That's okay. It kind of confused me while I was explaining it. Hopefully you got a sense of inheritance and polymorphism as features as aspects of object-oriented programming that you can apply in JavaScript using ES6 JavaScript. Thanks very much, and I'll see you later. All right. There's a discussion going on about all sorts of stuff in the chat that's very interesting. I think I'm finished for today. I don't know what's happened. There's apparently, I have no idea, by the way, the news is completely it's actually great to live stream because I am not looking at the news, I am not looking at Twitter, I'm not looking at my email. Who knows what's happened in the world in the last few hours? I guess I'm going to be returning my email, getting some lunch, having some appointments, some office hours and different things. I will be back next Wednesday. And next Wednesday, hold on. Tim is writing something. Tan said Java is strongly typed because you type confetti C, but that fact makes it explicitly typed, not strongly typed. Strongly typed means that a value sticks to its type. Oh, okay. All right, maybe. What I meant by strongly typed, and I was maybe being too informal with language, is that you have to specify the type of a variable when you declare it. So Tim, maybe what you could do when I publish the edited version of this that's in the tutorial playlist, if you can write a succinct explanation of the nuance of that, I can put it in the description or even like pin a comment. But I don't think there's anything like horribly wrong in what I said. And Simon writes, Python is strongly typed but not statically, so there is a difference between strongly typed and dynamically typed language. Yeah. Yes, that's explicit typing. All right. Maybe I should just record a little. All right. All right, I have an idea. Mathieu's going to work his magic here. Python is strongly typed, but you don't write types. I see. That's so true. I get it. I sort of get it. So what's the key definition of strongly typed? That's what I'm going to do here, as you're going to see. Alexi, I'm so sorry I never got to that. Hold on. So what does strongly typed mean? Get the browser back. A strongly typed program is one where each type of data is predefined as part of the programming language and all constants or variables defined for a given. Oh, strongly typed means you can't make up your own. Strong and weak typing. Right. What you said is confusing, Schiffman, because you're using strongly typed when you mean explicitly typed. Typing is already confusing is enough that it'd be nice to be right with the definition used. Strongly typed variables and objects inherently have a type that cannot be changed. If you assign a new type, you recreate and reassign the variable. Okay? Data structures and functions must know what types they operate on beforehand. Once you make the variable a given type, all right, okay. I get it, I think. Yeah, I'm reading the Wikipedia page also. I mean, I think I'm not the only person to be colloquial about it. Cannot reuse a variable going from number to string in strong types. Okay. Yeah. All right. Okay. So I'm going to try a little quick addendum explanation that will come in the middle. Mathieu will do his magic. One moment, please. So during this video, I referred to Java as a strongly typed language, and all the places I looked on the internet do describe Java as a strongly typed language. However, the aspect that I was explaining is really something known as explicit typing, meaning you have to say, if you're going to declare a variable p, I have to say what kind of data I'm putting in there. Is it an integer? Is it a float? Is it a particle? What strongly typed means is that that type could never change. It has to remain the same, and there's really like a lot of stricter rules around how that works. So like Python, for example, is also strongly typed, but you don't have to declare it's not explicit. You don't have to say what kind of type that variable is. You just can't change it later. It's got to work all when it's compiled. So there's a lot of nuance to that, and some I'll try to include some reading material in this video's description to explain that better. But what I really meant was explicit typing. Okay, now back to the video. All right. Tim and everybody watching, is that a kind of reasonable correction that would just like pop in somewhere in this video? Or do I need to do that again, whoops, with anything that I maybe said incorrectly? Whoops. Okay, so that will end up somewhere overlaid in the edited version. Okay, people are saying, even dynamically static says yes. Correction is okay, says Nathan. Thank you, everybody. You know, what's really kind of fun about doing this is I really don't know half this stuff. I mean, people think that I know all this stuff, and I'm just like figuring this out like the rest of you. And actually, this really helps my teaching here and all the other stuff that I'm doing, because I learned so much from people watching, and I really thank you for that. I was too close to the green screen. Mathieu is very good at his work with magic with Adobe Premiere, so it'll be fine. Python is really iffy, but it's mostly correct. Well, we'll see. All right, thank you, everybody. All right, so Alexi, that I apologize, asked about contributing to P5.js. So let me make a list. So unfortunately, I really have to go, and I don't have time to talk about that today, but I will say, if you're interested in contributing, I'm pretty sure there is a wiki page about getting started. This is where you want to go. So things moved. So this is like a short answer. If you're interested in contributing to P5.js, this on the wiki is where you want to kind of start. Right here, go to the GitHub repository wiki, and down here there'll be information about different ways to contribute, the community statement and code of conduct, an overview, and a development guide. So this is a place that you should get started. All right, I have got to go. So I really have to do this data stuff next week. The things that I didn't do is I didn't do the terrain. I didn't do my video that I imagined of redoing every single Perlin noise example that I ever made. Sorry, classic Perlin noise example that I ever made with OpenSimplex Noise. That I didn't do. I really for some reason I'm kind of on this idea of making a Rubik's Cube, so I do want to get to that at some point. And I really would like to make a processing library. I don't know when I'm going to do that. I want to come back and show Eclipse and how to make a processing library. All right. I'm going to go. So thank you, everyone. I am going to play you out with the MIDI version. I'm going to take some time here to go to System Preferences, Sound, and I think if I do the multi-output device, if I play this, you're going to hear this through. Yep. Oh, wait, hold on. So Matthew Gialarakis makes a really good point. I think a good thing to keep in mind is that other languages have arrays where the type of the array is dependent on the type of the contents. In Python, most of the time, the container is not defined by its contents. Yes, that's an interesting, okay, so I am going to I'm muting my microphone. I am going to the wallpaper. I'm going to play you out with this. Bye, everybody. See you next week on the Coding Train, every Wednesday, 10:30 a.m. Eastern. Nothing makes me happier than getting people's like weird musical remixes of my coding stuff. So if you're a musician and you're interested in doing that, please make them. I like to have more sounds and music to play. I will see you all next week.